Welcome to qnawire.
Here, we've defined first the coefficient of static friction and then the maximum velocity for a car traveling around an unbanked curve in two different scenarios. So let's start by drawing the free body diagram for our first scenario. The red dot here is our car moving along the curve. Then gravity, as always, will be pointing straight down, and the normal force will be pointing straight up from the curve to oppose it. But what's different about this problem is that we have another force pointing straight down. We're taking into account the air pressing down on the car, which gives us another downward force or downforce as it's called in the problem, which we're just going to label FD. Our final force is the force of friction, which as always in these problems is going to be pointing inward toward the center of the circle, opposing inertia. All right. So since F friction is the force pointing inward, that must be what's responsible for our centripetal force. And we know that the force of friction is always equal to the normal force times the coefficient of static friction, which is what we're looking for in this problem. The centripetal force is equal to mv squared over r, our radius. So in order to solve this problem and solve for the coefficient of static friction, we have to solve for Fn. Now, Fn has to oppose the two downward pointing forces in order for the car to not either float up or sink through the ground. So we know that the normal force has to be equal to the downward force plus the gravitational force. And since we know all these quantities, we can plug in and solve numerically. The downward force is given to us as being equal to 11,000 newtons, and Fg is just mg, which we are given. And G is 9.8 meters per second. Actually, let's write this on the next page. It's running out of space here. We'll write it somewhere else here. But you get the picture. It's 11,000 plus 830 kilograms times 9.8 meters per second squared. And when we solve that, we are going to find that our normal force is equal to 19,134 newtons. Now, we can plug into our equation for the centripetal force, and we can solve. So that normal force that we just found, multiplied by our coefficient that we're looking for, is equal to mv squared over r. We know m. It's 830 kilograms. And we know our velocity, 58 meters per second. Square that. And we're dividing by our radius, which is 160 meters. When we solve for the coefficient of static friction with our calculator, we find that it is equal to 0.91. And since it's coefficient, it doesn't have units. And that is our answer to part A. Now in part B, we're not considering the downward force anymore. We're just saying that if we go back to our free body diagram, that we're erasing this force right here. And then they want us to find the maximum velocity in this scenario. So once again, we're going to do something similar to what we did in this part of the problem, right? Where we said that, okay, we're going to find Fn using what we know about the forces that it has to balance, and from there we're going to find the centripetal force. So, once again, we're going to say that Fn times our coefficient of friction, which is just the friction force, is equal to mv squared over r, our centripetal force. Nothing new here. But what changes is that we know that Fn is equal to Fg, since it's no longer opposing the downward force. So this just ends up being equal to mg times the coefficient of friction being equal to mv squared over r. We cancel out our m's. We get that v, the max velocity that we're trying to find, is equal to g times our coefficient times r. Now, in this case, we can plug in our coefficient from earlier because remember that the coefficient of friction is just a property of the material that the road is made of and the material of the tires. It doesn't change when we change things like the forces acting on the road because it's a constant of the materials that we're working with. So when we plug in our numbers, we get that V is equal to 9.8 meters per second squared times 0.91 times 160 meters. And we find that V, our maximum velocity, is then equal to 38, and our units work out to be meters per second, which makes sense. That's a good sign that our answer makes sense as well. And that is going to be our final result for B.